So the question is a set matrix 0. So actually we are given a m into n matrix, m rows and columns, and if a element in any row and column is 0 set, so then we have to make that column and that row as 0. So basically it says like this: suppose if we have something like this, let me pen here. If we have something like this, basically 0 in this position, so we have to make its entire row, that is this, and entire column to be 0, basically. Okay, so this is what we have to do. The question is this. Okay, so now let's discuss the approach of the solution. So there are various methods to do this problem. So what I will do, I will tell two I will solve this question using two approaches. First, that will take more space, and then the one that will take less space, basically. So the first approach is something like this. First, what I'll do, I will take a queue and I traverse the graph, and if at any point I find 0, so suppose it's a row and column number is 1 and 1, so I'll push 1 and 1 basically in my queue. Basically the location of 1 and 1 in the queue I will push. Then I will what I'll do, when I empty the queue, when I traverse the queue, I'll find the column number and the row number. Then I'll make a separate function, and suppose this function is like this. It accepts suppose a row and a column and the matrix. Okay, so suppose this is the row. So suppose when I take out 1 and 1, 1 is the row and 1 is the column number. Now in this function, what I'll do, I'll just first through one loop, I'll mark this entire column to be 0. So the loop will something like this. For I, it will be from 0 to row, because we are filling the row now. Column will be same and we are filling the row 1, 2 and 3. So it will be from 0 to row. And what I'll do, matrix of this equals to 0. Now column is constant here, so I will put a column, basically this column, because this is constant, and row is changing, so I'll put I here. So in this way this column will be basically filled to 0. Now what I'll have to mark this row as 0. So again the same loop, but for row I'll put. So suppose for I from 0 to, this time we are traversing the column 1, 2 and 3, basically column. So matrix of something to something equals to 0. So basically in this case the row is constant, so this row is constant and I is changing, our column is changing, this. So through this loop our matrix, our row will be filled, and none of the 0 apart from this, its row and column will be changed. Okay, so this is the basically the solution. One solution, we can say it is the brute force solution. Its time complexity will be order of n square, and yeah, q order of n square at max, because one time we will be storing traversing the whole matrix to find the location of 0 0, and second time I will be traversing the queue, and each for each location I will be running this two loop, which is order of n times. So basically it gives me order of n square. Space complexity in this case will be, now suppose let take the worst case scenario basically. So all the if all the column and row will be 0, then our queue will be fully filled with all these location basically. So at max m into n, this is nothing but m into n, or this is not n square but it is m into n basically. So this is m into n, the space complexity in this case will be m into n. So first I'll code this and then I'll discuss the optimized solution. Okay, so let's move to the optimized solution of this question. Sorry, code the solution for this. So first, what I'll have to do, about I have to first I have to make a queue of pair. So QUE pair, queue of pair, enter and queue. Okay, so now I'll traverse. Let me first mark int n equals to matrix size int n equals to mat 0 dot size. Now int I equals to 0, I less than up to n, I plus plus. For int j equals to 0, j less than, j less than m, and j plus plus. Now if at any point I find a matrix of I and j to be equal 0, then I'll push that row and column to my queue. Basically, I comma j. Okay, so now our queue is filled. Now what I'll do, I'll while traverse the queue. Queue is not empty. What I'll do, I'll take out the row and column. So q dot front dot first is my column, and call equals to q dot front dot second. Okay, now I'll pop it. Now what I'll do, I'll call a function helper. So to which is the function, this function will be our helper function. So helper will accept the row, column and the matrix. Okay, so and after that we don't have to return anything because it is a void. And let void helper, so enter row and column, and let me copy paste this part, control C, control V. Now what I'll do, I'll first take out the matrix dot size. Let me copy paste also, or else I'll make a typo definitely. Okay, now what I'll do, I'll traverse I equals to 0, I less than. First I have to traverse from I to row basically. Okay, means I have to travel the all the row, not this row basically. This row and this row basically is not equal. This is actually the full row, that is in this case is n. Okay, and in this case it is nothing but m. Okay, so yeah, I is less than n, I plus plus. Now matrix of, so column will remain constant now. I of column equals to 0, and if I same loop will be for this up to m, column wise basically I have to move, and row will remain constant in this case, and this will be I. And this, thus the code is over and it will be submitted actually, because the time complexity in any case will be O of n square, m into n, not n square. Let me try to submit it. And yes, it is submitted actually. Sorry, my system is a little bit slow. Yeah, it is submitted. No, now let's discuss another approach. Basically, let me reset. Yeah, let me reset this code and discuss another approach. Fast. Okay, so the problem again was this. Okay, so let me make the matrix fast. One 0 1 So in the previous case, which was the brute force, I was using q, and in the worst case it will be o m into n, which is normally, if both are equal, o of n square, basically quadratic. We are obtaining a quadratic time space complexity, which is bad. So let's optimize the try to optimize the space complexity. So what I'll do, since we have so so what we have to do, basically understand this. So we have to first identify the zero and only mark its row and column all to be zero. Okay, so what I'll do, I'll take a separate array, two array, yeah, this plus and suppose consider these two array of size obviously 3, and this is 0 1 and 2, 0 1 and 2. So what I'll do, I'll traverse the graph, and at suppose yeah, okay. So when I traverse the graph, let me initially mark it with -1. Okay, so to avoid the confusion over here, so what I'll do, I will traverse the graph. At if at any point I'll find, suppose this index is 1 and this index is 1, I'll find 0, then in both the row, suppose I name it as a row, suppose row, and I'll name it as column. What I'll do, it's a row is this, so I'll mark here actually 0, and also I'll mark here 0. Basically what I'll do, in the row and column of this both array, I'll mark its row and column number. You're getting, so it as 0. And further, when I again traverse this sorry, this is 1, when I again traverse this array, so I will check two things. Okay, so the test case will be like this. If suppose I am calling it as a row of I equal 0, or column of j equal 0, basically. So if any of the condition is true, okay, so I'll mark that cell as 0. So when I traverse at this point, so let's check. It's a 0 and a 0, basically. It's a I and j vertex now. So if I check in row and column, 0 and 0, both are -1, so I'll not touch it. But when I come to this, 0 and a 1, so basically 0 in the row. No, 0 in the row is -1. But 1 in this column is a 0. So I have the condition as or. So if any of the condition is true, I'll mark it as 0. So again, when I move to this is 1, 0, comma 2. So again, 0 in this row of 0 is again -1, but column of 2 is again -1, so I'll not touch it. I'll not touch it. But when I move to this, so this is nothing but first row and 0 1 and 0. So I'll check row of 1 or column of 0. So row of 1 is 0. In this case, row of 1 is 0. So I'll mark it as 0. This is already 0, so it will be 0. And suppose I move to this. So this is 1 comma 2. Okay. So row comma 1 is 0, but column comma 2 is -1. So either of the one is 0 now. So I will mark 0 here. And similarly for all the cases. So in this case, so why this case is better than the previous, because in this case we are only using two array, row array and column array. Row array of will be size n, column array will be of size m, suppose. So the overall time complexity will be order of n plus m, and it is much reduced in the previous one, which was order of m into n. Basically it was taking order of m and space complexity, while it is taking just the summation of both the arrays, while the previous was taking the multiplication, means all the cells. And here we are not taking anything extra. We're basically taking, but since order of n plus m is very less than, so let's try to approach this problem. So what I am doing first, let's first declare the two array. Okay, so vector of int row. Basically it will be row of size. So let me first declare the size. Int n equals to matrix dot size, and int m equals to matrix I, sorry, 0 dot size. Okay, so n comma minus 1. I will fill this array with minus 1. Now I will declare another array of int column with size m and minus 1. Now what I'll do, when I'm traversing, when I traverse this array, so wherever I find 0, I'll mark both the row and column of that to be 0 in both the array. Okay, so let's traverse int I equals to 0, I less than n, I plus plus for int j equals to 0, j less than m, j plus plus. And if at any moment I find that matrix of I comma j equals 0, then what I'll do, I'll mark the row of I to be 0 and column, corresponding column to this, a separate array to be 0. Now this array gets filled. Now I again have to traverse the same graph. So let me copy paste this. Okay, so what I'll do now, only I'll remove this part, and I check if remove this also. I'll check if row of I equals 0, or column of j equal 0, that in that case the matrix of I comma j has to be 0. And now I think yeah, code is complete. Yeah, so now this is the only case. Basically this is only what we have to do, just check and update. Okay, so I think this is the some random error. Okay, so I am, let's suppose, oh, I was actually selecting that now, that's why it was giving error. Now it will not give error. Okay, again the same error. What I'm doing wrong here actually? Oh, I'm missing, I think, missing. I am missing the curly braces actually. Yeah, it is running fine, and the space complexity is much more reduced than the previous one.